We're gonna solve a quadratic by graphing. And in order to solve something, okay, you need to have some kind of goal. So first of all, here's our function or our equation. And this actually has many, many answers. Okay, it's a quadratic, you know, if it was on a grid. If we're looking at x at -5, here's an answer, and there could be answers here. There's actually an infinite number of answers along here. So in the question they've asked us, they want to know when y is 0. And we have to realize that when y is 0, we're talking about x-intercepts. So to solve it by graphing, usually when we solve something like this, okay, we'd set y equal to 0. So you're looking at, 0 equals x squared plus 2x minus 3. Okay, you would maybe factor, and you could find the roots, that's what they're called, the x-intercepts, maybe the best way. But let's say we have no idea how to factor. In fact, maybe this is a completely different equation, like it's the power of 4, or it has some weird equation or a weird mathematical thing in it that we've never seen before. You can always graph any equation or function by just building a table. Okay, and it's common in a table of values. What you do is you arbitrarily put in x values in, and then you plug them into the equation to find out a y value. It's common to put values that are around the origin to start. So stuff like -3, -2, -1, 0, 1, 2, 3. Okay, but sometimes those aren't the best points. That's the problem with this trial and error method. We might not find like critical values and stuff unless we're at like -100 or +1,000. Okay, it really depends on where the equation is on the graph. Okay, so that's why this isn't always the best method, but it is a method you can do. So sometimes even a teacher will give you a graph and it'll say something like, or maybe the graph will already have a scale, and we know it goes from the scale goes from -10 to +10, and they'll tell you to graph something. Okay, well, we know we can plug in any value from -10. 8, all the way to 8, 9, 10. And if we plug all these values in, we're bound to have a pretty good idea of what the graph looks like. Okay, so that's a way of choosing, because sometimes students are like, oh, how do I know which x values to use? Sometimes it's guessing. We just kind of try to make educated guesses. So like I said, we're going to make an educated guess, and we're going to do stuff around the origin. Now, when x is -3, -2, -1, 0 is next. Okay, 1, 2, and 3. I almost forgot there for a second. Now, we're in what's called standard form. Okay, and standard form is a x squared. Oops. What the heck? There we go. Plus bx plus c. Now, what's good about standard form is it tells us what the y-intercept is. The y-intercept is -3. Okay, and we know that's the y-intercept because if you plug 0 in, 0 squared is 0. 2 times 0 is 0. All you're left with is -3. So in standard form of an equation, we can find out that coordinate at least really quickly. We know one coordinate. Fortunately, it's not our solving. It's not when y is equal to 0. So we're going to plug these values in and try to see if we can figure out when y is equal to 0. So equation 1, 0 is equal to, we're going to plug -3 in to start. So we have -3 squared plus 2 times -3 up -3. Okay, so -3 squared is 9. This 2 times -3 is -6 minus 3. That actually ends up being 0. So 0 equals 0. We know that checks out. So when it's -3, our y value is 0. So we've come across one of them. That works out really, really nicely. What we're going to do is we're going to test the pattern and see where this goes. Usually, in quadratics that cross the x-axis, they usually have 2 x-intercepts. It's possible to have only one, okay, and there's algebra to prove it, but we can actually, here we go. We can use this information to decide whether we have 1 or 2 x-intercepts, okay? So again, we have to already have a little bit of knowledge about quadratics. But here's our general idea. We know the y-intercept's at -3, right? We got that. And we know this quadratic opens upwards. So if the y-intercept's at -3, we know it's not going down because the a value is positive. So if it's heading upwards, then it must have 2 x-intercepts. Okay, so we know we've got one. Let's test out a bunch of the others. I'm going to try to go through them a little quicker. So same idea, same equation. we're trying to see if the left side equals the right. 0 equals, and we'll test -2. Okay, plus -2 minus 3. This is going to give us 4 minus 4 minus 3. That's going to be -3. So there's a coordinate, okay, but that's not one of the values we're looking for. Then we plug in -1. And again, I could call this y or 0. I could say y equals, right? I kept 0 because they told us to find out when it's 0. But we could say y equals, and that's when the y coordinate is that value. Let's plug in -1. -1 squared plus 2 times -1 minus 3. This gives us +1, -2, -3, and that gives us -4. Okay? -4, there's another coordinate. We already know the next one's -3, because we know that's one of the y-intercepts. And quadratics tend to be symmetrical. I'm going to take an educated guess and say that this value is going to be 0. Okay? We'll test it anyways. At 1. 1 squared plus 2 times 1 minus 3. 1 plus 2 minus 3 is, y is 0. And here you go. So now, we can take these coordinates and essentially graph it. You know what I'll do? I'll make a better scaled graph down here. Okay, we'll create our little graph. There's our y and our x. So, our coordinates. At -3, we're at 0, and at +1, we're at 0. So we got those two values. So we'll say this is -1, -2, -3. So we're at 0. And at +1, we're at 0. Okay? In between that, please go up. There you go. -2 and -3 is a coordinate. -1 and -4 is a coordinate. Okay. So -2 and -3. So I guess we're going to have to extend this a little. -1, -2, -3, -4. So pull our scale down just a little. So -2 and -3 was another coordinate. -1 and -4 was a coordinate. -3 and 0 was a coordinate, right? So if we go to connect our dots now, I'm going to do the best I can. I'm usually not very good at this. Curve. Ooh. Soon I'll be into art. Here we go. Okay. We found when y is 0. One of them is at 1, 0. Okay. And the other one is at -3, 0. It just so happens, these critical values, we found a couple other major points. Here's a y-intercept. That's good to know for graphing. The y-intercept is at 0 and 3. And in that same process, because they tend to be symmetrical, we actually also found the vertex. The vertex happened to be at -1 and -4. So we solved a lot of information by just graphing this. Again, though, had we started, at 10 and worked our way down 9, 8, 7, we would have had values that are way, way, way up here. And it took us a very long time to get down here. So that's why we usually use algebra of factoring or completing the square, trying to isolate for the value of x instead of just arbitrarily trying values. Okay? But this is a style where you can technically graph any function by just putting in x values, plugging them in, and getting the y coordinates. Okay?